Hi, I'm Phyllis Lang, and welcome to Nightwear. This video is part 2 of a series that demonstrates the observing plan document as it might be used at the telescope. Part 2 covers static and dynamic data filters, sorting options, and the important best time to view and best order to view sorting option. And now, here's part 2. So let's get some of these out of the way. We'll get observed out of the way, position angle, inclination, the user columns, and I think for now I will get rid of the atlases with the exception of Pocket Sky Atlas. And that should do it for now. So I have most of my data on the screen at this point. And I want to filter this data perhaps by magnitude. So I'll click the magnitude tab and I want to set a filter. And let's choose planetary nebulae within the grasp of my telescope in the light polluted skies near my home. So the dimmest magnitude I want to see will be 12th, and I want to include the missing magnitude values. And in order to update the document, I need to click Run. So there we have it. Only items that have magnitudes less than or equal to 12 are shown. And I think that we can use the sorting feature by clicking in the column header. And if you can see this little gray up arrow, that indicates an ascending sort. And if we click again, you can see the arrows change to a down, and that's a descending sort. I'll go back to ascending. So the brightest object I have to look at this evening is 10th magnitude, NGC 1514, 1535, and so on. I've observed each of these before, so I know for a fact that these are available to my skies at home in my yard. Another thing you might notice is that there's a little green check box up on the magnitude tab. That will help you to remember as you observe where you've set filters and where you haven't. Let's suppose that I want to filter also by constellation. Let's suppose I only want to observe at the moment in Gemini. So I'll click Gemini, and again I need to update the plan report, so I need to click Run. And as you can see, that filter has now been applied too. So we have 2 filters in operation at the moment, and our sort order is maintained. So as you can see, you will need to run the document each time you change filters. However, sorting can be done when you are running in continuous mode. So that pretty well takes care of the static data filters, but there's another type of filter available to you, and that is a dynamic data filter, and that will apply the filter as the plan runs continuously throughout the night, and the data values in the report, as they change according to time, the filter is applied. So that, for example, the altitude, which changes with time, can be specified for 30 degrees minimum. And as we run the plan throughout the night, as an object reaches 30 degrees from the horizon to 30 degrees, it will begin to appear in the report. And as an object sinks beneath 30 degrees, it will not appear. So you have a dynamic filter in altitude, also in azimuth. There's one more data column that deserves a little extra explanation. It's one that you'll want to use frequently at the telescope when you're running a plan, and that's the best column. The best column represents the time that is best to observe an object and the altitude at that point in time. So I happen to know that the moon sets at 11:47 p.m. locally, so the best time to observe this object which is setting is right when the moon gets out of the way. So I can also use the best column for sorting purposes so that I can get the correct observing order based on objects that are setting earliest and at the end of the observing run, objects that are rising latest so that they achieve a higher altitude. So I can use the best sorting anytime during a real-time run of the plan. You'll notice that I can change the sort order, and I can clear the sort order in a column by clicking Control, click, and that removes the sort order. So I can rearrange data as I run in real time at the telescope. But again, the best time to observe data column is one that you'll particularly want to use as the plan runs in real time at the telescope.